In this next lesson, we're going to look at describing motion with these terms: position, velocity, and acceleration. So, before we jump into that, we do want to identify that kinematics is the study of motion, just so that we're all on the same page. When we say kinematics, we're just saying, what can we know about something that is moving? Or more broadly, how is something moving, which can include staying still. So there's the four key terms, or the three key terms that we're going to look at here. First is position, and position is just defined as a specific location in space. So I might make a dot right here. That's one position. This dot over here is a different position because it's a different location in space. And we typically represent it with an x and use meters as our unit. And for meters, if you want to abbreviate that, you use a lowercase m, just like this. Related concepts to position are displacement, which we represent with a delta x, and that's just the difference of two positions. So x minus x naught, or x minus x0. When we have this subscript 0, that's just referring to the initial value. You can think about like it's the 0th position. And then when I have no subscript, that's going to be the final position. So final and initial. And so when you subtract them, that's where you get this change in position. Notice that this here is going to be a vector quantity. The second term that we're going to talk about is total distance, and this is actually like, it would be like laying a string along the path and calculating the total distance traveled. So this is a scalar. So if you want to know what the difference is, if you imagine I start at this position here, and then I go up 1, 2, 3, 4, 5. Then I go to the right 1, 2, 3, 4, 5. And then that may only be 4, but you get the picture. And I go down like this. And then I go back to the left. So my total displacement, my final position minus my initial position, is 0. So displacement is 0 meters. But my total distance traveled is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my distance is 18 meters, if we're assuming each of these squares is a meter. So that's kind of the difference between those two. And then x would just be describing any one of these given spots with a number. Next, we're going to look at velocity. And that's the rate of change of position with respect to time. So how quickly is my position changing every second? That's my velocity. And it's represented with a v, and it typically uses the units of meters per second, which we represent as m divided by s in kind of shorthand notation. And I will point out, and I'll try and do this for the first couple weeks here, I really recommend you use this vertically stacked notation. It'll make your life easier down the road. I would avoid the slash notation. It becomes ambiguous with some of the things later. So sticking with the vertical stack is useful. It doesn't work typing easily, which is why you'll still see it often. But if you're ever handwriting it, do the vertical stacking because it'll make it much clearer for you. We can calculate this or show this by doing the change in position, so delta x divided by the change in time, delta t. And this right here we call v bar, and it's actually the average velocity. And that kind of makes sense from what you've learned before, which is that If you take the total distance, divide by the total time, that'll give you the average speed. You might have been going faster at certain points, you might have been going slower at other points, but overall, the total distance divided by the total time is the average velocity. Related concepts, speed is velocity without direction. So it's the magnitude of the velocity. Let me write it that way because that will be a bit clearer. So if we don't tell you the direction, or you're not talking about the direction, then you're referring to speed. So it is the magnitude of velocity. So they are not the same. Speed and velocity are different in physics. Velocity has a direction, speed does not. So if I tell you I'm going 10 meters per second east, that's a velocity. If I just tell you I'm traveling at 10 meters per second, that's a speed. Average velocity, like I said, it's related, and you can calculate it up here. The instantaneous velocity, you would have to calculate using a different method that we'll show you later on. But that kind of gives you the heads up there that there is a slight distinction that we don't always have to calculate averages. The last term that we're going to look at here is acceleration, and this is the rate of change of velocity with respect to time. So what velocity is to position, acceleration is to velocity. So how much your speed is changing every second, that's your acceleration. So if you went from 10 meters per second to 15 meters per second, your change in speed was 5 meters per second. And depending on how long that took, that will tell you your acceleration. We typically represent it with a lowercase letter a, and it uses the units of meters per second squared, which if you want to write that in kind of shorthand, it's m over s, and then we just square it like we would with a variable. Please also note it's vertically stacked, and these aren't variables, they're units. To calculate acceleration, we're going to do the same thing we did before, and a bar is delta v over delta t. So like I said, it's exactly analogous to what velocity was to position, so we get the same calculation here. And so for related concepts, we do want to just take note that this is an average velocity, it's not an actual velocity. So now, an acceleration is the rate of change of velocity. So one thing to bear in mind is because velocity is a vector, you can also be talking about the velocity turning. So if I was traveling in this direction and now I'm traveling in this direction, I might still have the same speed, but because my direction changed, my velocity changed, and therefore I would have had an acceleration.